All right, so the second sheet, number 1. The coefficient of friction is 0.3. How much horizontal force is needed to pull a mass of 15 kilograms across a level board at a uniform velocity? Uniform velocity means AX is 0. Okay, and so we start with some of the forces in the y direction, and this is not moving in the y, and so it'll be Fn minus Fg equals 0, so back to the easier ones. So Fn equals Fg equals mg. So Fn equals 15 kilograms times 9.81 meters per second squared. And I didn't do that out, so 15 times 9.81. So you get 147.15 newtons. Okay, then if you wanted to, you could do FFR is equal to mu Fn. I'm saying if you wanted to because before long I'm going to start to encourage you to carry your letters instead of your numbers. But since I've already written this down, multiply your normal force by 0.3 and you should get 44.145 newtons. And now we go to the x direction. Sum of the forces in the x direction equals max, but it says, whatever it said, uniform velocity. So it'll be F minus friction equals 0. So F equals friction equals 44.145 newtons. Your answer to number 1. Number 2, a cart. A cart with a mass of 2 kilograms is pushed across a level desk. So this is 2 kilograms. This is Fg. This is Fn. It's pulled across a level desk by a horizontal force again. Okay, so F, and it's 4 newtons, it says in the question. Friction will be going back this way. And it says the coefficient of friction is 0.12. And it wants to know what is AX. So just like we did up here, some of the forces in the y should be equal to MAY, which will be 0. And so it'll be Fn minus Fg equals 0. So Fn equals Fg equals mg. And just for fun, let's just carry that mg. Yeah, you could multiply 2 by 9.81 and get 19.62, but let's not. And then you could do friction is equal to mu Fn. And so you could do friction is equal to mu mg. And yeah, you could fill your numbers in, but instead let's carry it. Okay, and let's go to sum of the forces in the x equals max. So it's F, not Fx this time because it's not at an angle, minus friction is equal to max. And F is 4 newtons and friction is mu mg. And to get the A alone, divide by m. And then, like, I would go to here, and now I would fill my numbers in. So AX is equal to 4 newtons minus 0.12 times 2 kilograms times 9.81 meters per second squared, and then divided by 2 kilograms. So I would wait and fill my numbers in here. That way I don't have to worry about rounding. I don't have to worry about units until the very last step. And then when we do that, you should get 0.8, if only I could see, 23 meters per second squared. Okay, so that's number 2. Number 3 says the acceleration of a moving 400 kilogram car. So my car is 400 kilograms. The acceleration is AX 0.55 meters per second squared. And the frictional force acting on the car, so the frictional force, they're being nice, is 800 newtons. what must be the applied force? So we're looking for this forward force, F. Oops, there's not really anything there. And then the second part wants to know what is the coefficient. Okay? So if first we're looking for F, we could do that first if you want. Some of the, since it's part A, some of the forces in the x direction. And so it'll be, that's just an error there. F minus friction is equal to max. And we're looking for this F. So F is equal to max plus friction. M is 400 kilograms. A is 0.55 meters per second squared, and friction is 80 newtons. 220 plus 80 should be 300, I believe, newtons. And then the second part wants the coefficient. So to do the coefficient, we need to find the normal force. So sum of the forces in the y equals may, and it's not moving. So Fn minus Fg equals 0. So Fn equals Fg equals mg. And if you didn't want to put your numbers in, instead you could just go FFR is equal to mu Fn. So mu is equal to the friction that you were given over Fn. So mu is equal to, what was the friction? 80 newtons. 80 newtons, and Fn was mg, so 400 kilograms. So this is really FFR over mg, times 9.81 meters per second squared, right? That's from there. And when you do this, you should get a mu of 0.0204. Number 3. Number 4 says a 40 kilogram box is being pushed across a level surface by a force parallel to the surface. If the coefficient of friction is 0.25 and the acceleration is 3 meters per second squared, what is the force the box is being pushed with? So here's Fg, here's my Fn, this is my friction going backward, and I am looking for this F. So I'd start with sum of the forces in the y equal to may. It goes to 0. So Fn minus Fg equals 0. So Fn equals Fg equals mg, and I wouldn't fill my numbers in. And then, of course, so then friction is equal to mu Fn, so it's just going to be mu mg. And I wouldn't fill my numbers in, even though I could. Instead, I'd go to sum of the forces in the x direction. And in the x direction, we have the F that we don't know, minus friction, is equal to max. So take friction to the other side, where you add it. And so it's really F is equal to max plus mu mg. And now I would fill my numbers in. F is equal to, m was 40 kilograms. A was 3 meters per second squared. Mu was 0.25. Uh-oh. Sorry, I think my camera flipped around and I just didn't want it to do that to you in the video. 0.25 times 40 kilograms times 9.81 meters per second squared. Do the math, and you should get an F of 218.1 newtons. Now, if you'd filled your numbers in all the way along, that would be fine too. This would have been 392.4 newtons, and this one would have been 98.1 newtons. I'm just trying to get you used to not working with letters, so when you have to, you can. Okay, so those are the first 4. Next video will be the next 4, because we're about out of time. But since it hasn't shut off yet, say number 5 says a curling stone is thrown forward on the ice.